Greetings to Professor Dr. Zainab. In this video, we are going to present our research proposal, which is the synthesis of molecular imprinted polymer for the removal of aspirin. These slides were prepared by Ivan Teo Yen Kai, Limi Meng, and me, Izami bin Sufyan. The contents of these presentation slides include introduction, literature review, problem statements, objectives, methodology, expected outcomes, and work plan, whereas introduction and literature review will be presented by me, while problem statement, objectives, and methodology will be presented by Limi Meng. Last but not least, expected outcomes and work plan will be presented by Ivan Teo Yen Kai. Okay, so for introduction, aspirin is a commonly used drug in our daily life as it is used to treat our headache, to reduce swelling, and also reduce fever. Don't get it wrong, however, as aspirin is not the same as paracetamol and ibuprofen. So the molecular formula of aspirin is CH3 COOC6H4 COOH, and it may be hydrolyzed into salicylic acid. On the right bottom, you can see that the molecular structure of aspirin is as such, and on the left bottom, you can see one of the most commonly used brand of aspirin. However, aspirin can be dangerous for the older adults to consume as their kidneys grow less able to filter the blood due to their age. So, aspirin, which is one of the medicines that are needed to be cleared by the kidneys, will accumulate in the bodies and causes poisoning. These symptoms of overdose aspirin, or most commonly known as aspirin poisoning, is said to have caused over 3,000 deaths of uh, older adults patient in a year. So it is important for us to find a way to remove this aspirin from our human body, especially among the older adults patients. Recently, scientists have came up with this molecular imprinted polymer, which is a class of synthetic polymers that are synthesized from functional monomers and cross-linker molecules with a template present. Uh, this kind of polymer was said to give some uses in the medical field as they are akin to antibody-antigen system in the human body. Generally, the removal of aspirin can be understood through the mechanism of lock and key model, as the MIP, the molecular imprinted polymer, also possesses this kind of quality. In the literature review, we have done some study on the procedures of synthesizing MIP, whereby the procedures in short is to arrange the functional monomers around a template in the presence of large amount of cross-linkers, followed by techniques called copolymerization. This copolymerization techniques is said to be highly sensitive, highly stable, and it is budget as it only requires a small amount of money to done the process. Other than copolymerization imprinting techniques, we also has the bulk imprinting techniques, the surface imprinting techniques, and also the epitome imprinting techniques. Other than the types of imprinting techniques being reviewed in the literature review, we also review the properties of MIP that is suitable to be used in removing the aspirin from human body. So the properties of MIP include high chemical and thermal stability, as it means that the MIP can be used in many situations as it will not decompose easily in the human body. The second one is fast and good absorption. This is important to treat overdose of aspirin as soon as possible, especially in emergency situation. So the third one is good selectivity, whereby it is important to ensure that the molecular imprinting polymers has high selectivity to aspirin only and leading to low risk of MIP reacting with other compounds in the human body. So last but not least is the capable of being reused. This is important to ensure that the amount of MIP used is sufficient to remove the excessive aspirin in the human body.
Hi, my name is Lim Yimeng. Today, I would like to present problem statement, objective, and methodology. In problem statement, we would like to know what is a suitable template for MIP to achieve selectivity toward aspirin. Property of the MIP synthesis should determine, and is it safe to consume by human? Lastly, is it possible that MIP is used in pharmaceutical use? Objectives for this research proposal are to synthesize molecular imprint polymer to remove aspirin. Characteristic of MIP should be determined, and the analysis of binding reaction between MIP and the aspirin in the body. Material used to synthesize MIP are aspirin, methyl methacrylic acid, trimethylpropane trimethylacrylate, styrene, benzoic peroxide, methanol, nitrogen gas, chloroform, and acetic acid. Instrument required to determine the characteristic of MIP and the analysis of binding reaction between MIP and the aspirin are extraction column, UV visible light spectrophotometry, and FTIR. Two solutions will be required to synthesize the MIP. For the first solution, aspirin template will be dissolved in ethanol and methyl methacrylic acid will be added in. Next, the mixture will be stirred ultrasonically, and finally, the cross-linker of trimethylpropane, trimethylacrylate, and benzoic peroxide will be added in. For the second solution, aspirin template will be dissolved in ethanol, and the styrene will be added into the solution. Both solutions will be bubbled in nitrogen to be used as pre-polymerization solution. The rubber tube will be sealed and allow the polymerization occur overnight in 60°C water bath. After the polymerization has been done, the MIP will be washed in a Socklet extraction device with a mixture of 9:1 ethanol acetic acid solution. Next, MIP will be dried in the oven. The extraction of MIP will be done where the sampling device acts as an extraction needle has a column that was filled with the prepared MIP. Extraction of aspirin will be done by solid phase extraction, where the aspirin will be dissolved in ethanol. Property of MIP will be identified through absorption kinetic, binding isotherm, and absorption of material with structure.
Hello everyone, my name is Ivan, here to report on the expected outcomes and the work plan on this research proposal. So our MIP synthesis is based on Pharma et al.'s methodology. So we believe that the MIP synthesis will have the same characteristics as Pharma et al.'s MIP. So this means that one of the properties stated in that research will be that the MIP will react exclusively with aspirin only. This, which means that once this MIP is consumed, it will not react with other biological molecules and lead to interference in biochemical processes. Also, according to our review in their characteristics, we believe we will expect that the MIP will be capable of removing aspirin in the human body because it has high chemical and thermal stability, which ensures that once it is consumed, it will not, instead of reacting with aspirin, it will not decompose instead of reacting with aspirin. So it is guaranteed that their reaction can be achieved. Furthermore, this characteristics also shows that it will be less likely that this MIP will cause harm to the human body. So it will contain properties that makes it safe to be consumed. With all this in mind, we believe that this will open up a new possibility in treating aspirin poisoning. Hopefully, it will be something self-applicable and simple, such that if someone had aspirin poisoning, they won't have to be hospitalized, or they won't be needing medical medical attention. They can just consume tablet and cure themselves from aspirin poisoning. So moving on to the work plan, we decided to use 10 months for this whole research. We had used 3 of it, April to June 2022, for literature review and preparations of material and instrumentation. And we will be using the next 6 months, which is from July 2022 to February 2023, to synthesize the MIP, sample it, and extraction of aspirin. And then we analyze it with FTIR, followed by the characterization of MIP, and then report on our findings. We decided to give this much time for all of this section due to we wanted to make sure that our findings, our research is done properly there, and to avoid any errors as possible, as much errors as possible, and also to account for unexpected findings so that we can have more time for further research. But if all goes well, we'll be doing the final report submission and presentation in February 2023. And yeah, so this is all I have to report. Thank you for watching.